Welcome to the fourth lesson in Session 8 on solving polynomial equations. A polynomial equation is any equation that includes a polynomial. In this lesson, we're going to use the rational root theorem and synthetic division along with the fundamental theorem of algebra to solve polynomial equations of degree 3 and greater. Now we have methods we can use to solve many polynomial equations. Linear equations can be solved using inverse operations and isolating the variable. Quadratic equations can be solved using a variety of methods like a quadratic equation, completing the square, factoring, and solved by taking the square root. All of the methods that we learned in Session 6. In this lesson, we're going to learn how to solve polynomial equations of degree 3 and greater. To do this, we need to understand what a depressed equation is. A depressed equation is the resulting equation that we get when dividing out the root of an equation. For example, if I had the function f of x equals x to the third minus 3x squared plus 7x minus 10, and I knew that 2 is a root of the given equation, then I would use synthetic division to divide out the 2, leaving me with the result 1, negative 1, and 5. Now I use the quotient to build the depressed equation. So the 1, negative 1, and 5 become x to the second minus x plus 5 equals 0. That's the depressed equation. It's the result that we get after we divide out a root. Now notice, if I start with a third degree equation that I started with, and I divided out one root, then the depressed equation becomes quadratic. So dividing one root out of an equation reduces the degree by 1. Now we're going to use the rational root theorem in synthetic division. We can break a polynomial equation down into a solvable quadratic. So the equation I'm given is 2x to the third minus x squared minus 7x plus 6. So I've got a third degree equation, and I expect to have 3 answers. Now they could be rational, irrational, or complex. Keep in mind, you understand that irrational and complex numbers always come in pairs. So we're going to start by using the rational root theorem to make a list of possible rational roots. So my value of q and p is plus or minus 1 and plus or minus 2, and so is q. So my possible values of p over q are plus or minus 1/2, plus or minus 1, and plus or minus 2. So we have 6 possible rational roots. Now notice we have a third degree equation. Finding one rational root will provide us with a quadratic depressed equation. Now if we can break our equation down into a quadratic, we have methods of solving quadratics. So that's my goal. I need to find one rational root that will allow me to write a depressed equation that's quadratic that I can solve. So using the 6 possible rational roots, you stumble across 2. So we know that 2 is a solution to the equation. Now when I divide out the 2, my depressed equation is 2, 3, and negative 1. So as I build that, I end up with 2x to the second plus 3x minus 1 equals 0. Now I have a quadratic equation that I can solve. In this case, with the equation that we're given, we're going to solve using the quadratic formula. So I take the opposite of b, plus or minus the square root, b squared minus 4ab all over 2a, and I begin simplifying. We end up with x equals negative 6 plus or minus the square root of 89 over negative 2. Combine that with the 2, and I have the 3 solutions. 2 and 6 plus or minus root 89 over 2. In the last example we have, we're going to do the same thing. We're going to use the rational root theorem and synthetic division to break down an equation into a solvable quadratic. Now notice in this equation we have a fourth degree equation. So we need to identify 2 rational roots in order to calculate a quadratic depressed equation that we can solve. So f of x is equal to 6x to the fourth plus 35x to the third minus x squared minus 7x minus 1. My values of p are plus or minus 1. My values of q are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Therefore, my values of P over Q are as given. So I've got 8 possible rational roots. Now notice there should be a plus or minus here in front of the 1/6. So I've got 8 possible roots to test, and I need to find 2 rational roots. So we start going along, and from working on this equation in the last session, we know that the rational roots are 1/2 and -1/3. So here you see we divide out 1/2, and our depressed equation is 6, 38, 18, and 2. So now these are the values we're going to use to write the next equation. We now use that quotient for the second rational root. And we end up with 6, 36, and 6. So 1/2 is a rational root, and -1/3 is a rational root. We now calculate the depressed equation and solve. So bring that over here, and we get 6x to the second plus 36x plus 6 equal to 0. We can divide out a 6 out of the equation, so we're going to do that and get x squared plus 6x plus 1 equal to 0. This is a good candidate to complete the square, so I move the subtract 1 to both sides, and I need to add 9 to both sides in order to complete the square. Doing so gives me the quantity of x plus 3 to the second power equal to 8, and when I take the square root of both sides and solve for x, I get x equals -3 plus or minus 2 root 2. So the solutions of this equation, I found 2 solutions using the rational root theorem in synthetic division, and they were 1/2 and -1/3. I then used the depressed equation and created a quadratic that I solved using completing the square, which produced the other 2 solutions, which is -3 plus or minus 2 root 2. So I had 4 real solutions, 2 rational solutions, and 2 irrational solutions. So that wraps up our lesson and really completes the course. So good luck on the quiz and the test. Please email us if you have any questions.